Okay, so this question is k largest element in array. So the idea is pretty simple. So what you need to do is you will have a nums array and then the integer k. So you want to return the k largest element. So you can sort this array, and then after you sort it, so it's gonna be 1, 2, 3, 4, 5, and 6, right? So the k largest, which is represent the second last, the second k index. So second k index, which is 0, 1, 2, 3, 4, right? 4, and then the element is 5, right? So this is gonna be a 6 minus 4. The length is 6, and then the k is actually equal to 2, so which is you end up 4, right? And the index is from 0 to 4, right? So the easy solution is I sort it, Arrays.sort nums, and then you return nums length minus k. And this is an easy one. Alright, the time and space pretty straightforward. This is time, n log n, right? And then space is constant, right? And then the next solution is going to be like this. Using a priority queue, right? PQ, and then whatever you have, you push into the priority queue. And if the size of the PQ is greater than k, then you pull, right? And this is going to be pretty easy. And the priority queue, you can just sort the element from the smallest to largest. And then whenever you pull, right, you definitely pull the smallest one. And basically this is it, right? So whatever you inside the PQ, right, at the front, after you traverse the full loop, right, after you traverse the nums array, the first index is going to be what? The k elements largest. So imagine this is 5 in this example, and definitely there's a 6. And when you pull the first index out of the PQ, is the 5, right? So k, this is the k element. So if you don't believe it, let's just start coding. Priority queue integer PQ new priority, and then okay, now I need to traverse the nums. So whatever I do, I need to add a num into the PQ, and then if the PQ size is greater than k, PQ.pull, right? And then later on you can say PQ.pull to pull the element from the priority queue, right? And this is pretty straightforward. And you can also use a peek, right? So the time and space is pretty straightforward. Priority queue using a log k y, because every single time if the size is greater than k, you'll pull, so it's going to be log k. But inside the log k, you have the for loop, so it's all of n log k is the time. Space is going to be all of n. Space is going to be all of k, right? You only have k element inside the PQ, right? So this is a solution. So I have another one. The next one is going to use the QuickSort solution. So QuickSort is the element that you have a pivot, right? You have a pivot, and then once you sort it, this is already sorted, right? So you just check the index. If this pivot is equal to the index k, then basically you can just return right away. So everything else you don't need to worry about. But this method is pretty advanced. So if you don't know the QuickSort solution, you can just watch the video and then know the idea. And I'm going to just stop coding because I assume you know what does QuickSort mean, right? So I have a starting index, and I have ending index, minus 1, and I also know my return index, which is the k largest element index. So it's going to be nums.length minus k. So okay, so while the start is less than n, so I need to find out my pivot, right? So pivot equal to what? Let me just call partition. I'm going to create a helper function for partition and just put in the start, put in n. So if my pivot is actually equal to the index, right? I can just return nums at what? Index, right? It doesn't matter if it's pivot or index. and also else if a pivot is actually less than index, which means what? I need to move my stop pointer to pivot +1, which is too small, right? And then else if pivot greater than index, and which is too big and equal to pivot -1, and everything else, right? We will just turn num_set star. Now let's talk about the partition function. So partition is actually like actually this is better, right? You're using partition and then there's a low and high. So just keep checking for increasing from the smallest to the index, and then you also have the largest to the index you need to swap. So just for example, if this is star and this is n, right? When you compare, so definitely you will definitely have a assumed value. So the assumed value is going to be what? It's going to be 3. The index 0, which is 3, right? Star equal to 0. You are passing the index, so the nums a star is actually equal to 3. Alright, so I need to compare it. If this is increasing order, right, and this is decreasing order, and if you avoid the, if you are in a conflict, then you need to swap. So in this one, like star is right over here, right? 3 is actually equal to 3, so let's not worry about it. So I will increment my index to 2, but 2 is less than 3, so I need to stop at this one. So this is I index, and this is 4, right? 4 is actually okay, right? So 4 is less than, 4 is greater than 3, that's okay. And you move the j index to the next one, which is 6, and then 6 is greater than what? Greater than 3. Move 5. 5 is greater than 3. You move 1. 1 does not greater than 3, right? So in this one, you need to swap these two elements, j and I. So once you swap, one of them is already sorted, right? So you will become like this: 1, 2, 3, right? And then you need to swap 3 with this element. This is because of QuickSort. You know this is definitely the position you need to sort. So 3 is already sorted, right? So if you know like the sorting array for 1, 2, 3, 4, 5, 6, this is already sorted, right? Let's just remove this. So we know this is sorted, so we are not moving. And if this index is k index, if this is k index, then we know we can return this. But this is not, right? Then we just keep doing the same thing, right? We need to find out another partition for the left and another partition for the right. So this is a solution. So yes, basically I repeat the QuickSort solution. Oh my god, okay. Yes, okay. So public int partition in nums array in star in n, and I need a pivot for star, and while star is less than equal to n, because we are comparing the index. Index is already starting from nums of length -1, so you have to use a less than equal sign, less than and equal sign, right? So I need to still keep checking when I want to move my nums to star. If this is less than nums pivot, right? And star increment, right? Well, star is still less than equal to n, and nums n, which is what, greater than nums pivot, then what, n minus minus. Alright, so if the n is greater than star, right, this is not allowed and we break. So we don't need to swap. But what happens if the star is less than equal to n, right? You need to swap, right? Nums say what? Star and n. I need to write public void swap in nums in I in j in 10 equal to numset I, numset I equal to numset j equal to 10. Alright, so when you swap, right? After you swap, you still need to swap the pivot with what? The pivot with the n, and then you will return what? You will return the n, right? Because you know the position you sort. Just for example, the 3 was like moving from here to here, right? So we know this index is already sorted. Then we back to the what? We back to the for loop, while loop, sorry. Then we compare the index. So, oh, I made a mistake. Okay, I found out my typo. So, n is definitely greater than star, right? But when you change the star index and n index, if the star is greater than n, right, you need to break. Then you swap the n pivots. So this is the mistake I made, and I'm sorry. So the time and space for this solution. This is gonna be what? This is gonna be all of n, right? And inside the all of n, and this is another all of n, right? So just for the worst case, you will keep comparing, right? So my assumption for the time is going to be n squared. And if you look at this time complexity, time complexity for the QuickSort for the worst case n squared, right? And the space complexity should be constant. You are not allocating any space. So once again, I made a typo right over here. So if you can fix this, this will be good. So everything else will be good, and this is going to be total 3 solutions in this video using Arrays.sort, priority queue, and then QuickSort. So I will talk to you later. Bye.